Hey guys, here's example 1 from 3.4. A particle moves along a line so that its position at any time when time is at least 0 is given by the function s of t equals t squared minus 3t plus 2, where s is measured in meters and t is measured in seconds. Part A. Find the displacement during the first 5 seconds. So displacement is s of b minus s of a. Well, we know the first 5 seconds, meaning that we end at 5 and we start at 0. So s of b is 5 minus s of 0, which is a, equals, I plug it in. Here we go. 1 minus the other equals. S of b, time is 5 seconds, 5 squared minus 3 times 5 plus 2. Over here, when s is 0, everything cancels except 2. That's 25 minus 15 plus 2 minus 2. Those two are canceling, so 10. So the displacement during the first 5 seconds will be 10 meters. Okay, so the displacement during the first 5 seconds will be 10 meters. B, find the average velocity during the first 5 seconds. Average is delta S, divided by delta time. Well, that's really mean the time, the difference in position, which is s of b minus s of a, all over your t2. So that's 5. Oh, what happened? 5 minus 0, because b is 5 and s of a is s of 0. Well, we found that this is pretty much then the displacement. Okay, s of b minus f of a. This is just the displacement divided by 5. We found the displacement from the top, which is 10 divided by 5. So the average velocity during the first 5 seconds is 2 meters per second. Okay. Find the instantaneous velocity at time equals to 4. Instantaneous meaning that we have the velocity. Instantaneous rate of change is now the derivative of your position. So which means the velocity. The derivative of the position is, your original was t squared minus 3t plus t. Based on the power rule is 2t minus 3. We're looking for at time equals to 4. That's 2 times 4 minus 3. So this is 5 meters per second is the velocity at t equals to 4. D, at what values of t does the particle change direction? And based on your notes for cap before, it changes direction when the velocity equals to 0. Velocity, it is right here. Okay, so velocity equals to 0. That means 0 equals 2t minus 3. So solve for t. T comes out to be a positive 3 over 2. So the particle changes direction at 1.5 seconds, or you can write 3 over 2 seconds. Either one's fine by me. E, where is the particle when s is a minimum? Okay, s is talking about the position. Minimum, remember, the position was given to you. Let me move it. Oh, it's frozen. Okay, the position was given to you as in, and it's, oh, there you go. The position was given to you in terms of t squared minus 3t plus 2. So that's a parabola. It's an opening up parabola. So a minimum is really down here at the vertex. Well, the vertex is when the slope is 0. Well, the slope is 0 is when the velocity is 0, and we found the time when the velocity was 0 at t equals to 3 over 2. So it says where, okay, not when. When, that means the time. It's looking for where. So we will plug in the time. So the position is 0. It's at the minimum at the time of 3 over 2. Excuse me. So I will plug in 3 over 2 to your position formula, which is t squared, which is 3 over 2 t squared, minus 3 times 3 over 2, take away, I'm sorry, not take away, plus 2. So that will give me 9 over 4 plus 9 minus, not plus, minus 9 over 2 plus 2. That will give me a negative quarter. So what does that mean? It means, I'm going to write it out for us. Okay. When S is a minimum, the particle will be at meters. So the particle will go lowest. In this case, I can't really say lowest, it wouldn't even be right because it's going left to right. Will go as far left as negative 1/4. Okay. Now technically you can stop right here if you need to. If you have physics and you understand all of the particle stuff. If you don't, this is just sort of a side explanation of what all of this means. So you were given, let's go back here really quickly. You were given a particle and it says it goes horizontally, okay, moves along a line. So a line is really talk about horizontal. So here's your displacement. This is your S. Then it said this is in terms of time. So we'll 2, 1, 0, -1, and -2. We'll go to 3, 4, and so on. So this is where the object is at. This is moving along a number line. Well, if I were to make a table, it will give you a better understanding. So S of t equals t squared minus 3 times t plus 2. And again, if you understand all of this already, you don't need to listen to this any further. So at time equals to 0, because it said time has to start at 0 or bigger, because time can't be negative here. So when I plug it in, the object starts at 0. So on my position, the object starts at 2. At time equals to 0, the object starts at 2. Okay. If I keep on going, okay, so I'm going to go pick my green pen back. 1 second later, I'm going to plug it in. 1 squared minus 3 times 1 plus 2. That's going to be -2 plus 2. That would be 0. Okay, 1 second later, I'm going here. So I'm currently at, wait, not there, at 0. My bad, I just wrote 0. Okay. A second later, so what that means is I'm really going left, okay, again. 1 second later, I'm currently at 0 on my number line. That means I'm going left. Well, technically, I should really put in 2 seconds later. But remember, when we did this down here, we said it turned around, the object turned around at 1.5 seconds, okay? What does that mean by turn around? It turns around means I originally started going left. It turned around here. So if I plug in 3 over 2 quantity square minus 3 times 3 over 2 plus 2. And we did this math right here already, okay? This right here said it came out to be a -1/4. So at 1.5 seconds, okay, at 1.5 seconds, that means I'm here, a -1/4. I'm still going left, okay? So at 1.5 seconds, the position is -1/4. Well, let's see if it's really true. If we plug in time equals 2 and it gives us a value that's bigger than a -1/4, then we knew for sure that it did turn around. So 2 squared minus 3 times 2 plus 2 equals 4 minus 6 plus 2. Oh yeah, that's definitely bigger than 1/4. So 2 seconds later, get a different color. Let's get blue. 2 seconds later, I'm back at a position of 0. So look, I'm really turning around. What if I pick 3? 3 squared minus 3 times 3 plus 2. So this is going to be 2. Wow, 3 seconds later, I'm actually here where I started. So 3 seconds. It took me 3 seconds to go back to where it was started. What if I pick 4, 5, 6, 10 seconds later? Is it ever going to go to the left again? So when I pick 10, 10 squared minus 3 times 10 plus 2, so this is really 100 minus 30 plus 2, so 72. So 10 seconds later, I am like all the way over here, which my number line doesn't hold. So as you can see, it went left, okay? It started out going left. It started out going left until 1.5. And then it went right indefinitely. Okay, so this is really what's going on with this object. I know, it's really cool, right? We'll touch more on that later. But right now, that's what all of that connection is. All right, until next time.